and in the previous video we have given an introduction on a Fourier series. In this video we will be deriving the equation or the formula for the coefficients, and how it came into being will be discussed here. Okay, concept wise lecture will be here. So let us consider two signals, one of 1 Hertz and the other of 0.8 Hertz. Okay, so I am going to draw it over here. Please have a look at this. So this is 1 Hertz, 2 Hertz, 3 Hertz, 4 Hertz, 5 Hertz, etc. So let it be till 5. And this represent one cycle, first cycle, this is second cycle, this is third cycle, this is fourth cycle, and this is fifth cycle, right? And now I'll draw for 0.8 Hertz as well. For 0.8 Hertz, it is around the time axis. Okay, so for 0.8 Hertz, it will be 0.8 Hertz, then time will be 1 divided by 0.8, that is, time period is 1.25 here, right? 1.25 seconds. So I'll take it as 1.25, period as 1.25. okay, 1.25. next one will be 2.5, next one will be 3.75, and the last one will be 5 itself, right? So this is our first cycle, this is our second cycle, this is our third cycle, and this is our fourth cycle. Okay, and now if these two signals are added together, we can see that both these signals start at 0, right, and end at 5 seconds only. So that the thing is that both of them repeats itself after 5 seconds, right? So the resultant form will also repeat itself after 5 seconds only. So if I am going to add these two, this represents one cycle, right? It will be like this. And the nearest 0.25 seconds, that a portion of the signal will also be taken. So it represents one cycle, that means one oscillation will be there for 1.25, and the second one will be 2.5, and the third one will be 3.75, and the fourth one will be 5 seconds as well. The thing is that it will repeat itself, this pattern will repeat itself after 5 seconds only. For better understanding, I am going to take two signals of 0.4 Hertz and 1.2 Hertz. Okay. For one cycle, for one cycle, how much time it will take? 1 divided by 0.4, which is equal to 10 by 4, which is equal to 5 by 2, right? For this one cycle, we will get 1 divided by 1.2, which is equal to 10 divided by 12, or 5 by 6. So let's have a look here. This is 5 by 2 seconds, and the other one is 5 by 6 seconds. From here, observing, from here we will know that this 5 by 6 is actually 1/3 of 5 by 2, right? So the time period of the 1.2 Hertz signal is actually 1/3 of 0.4 Hertz signal. So if I plot it, it will look like this. Our 5 by 2, when 5 by 2 have a 1 cycle, 5 by 6 have 3 cycle in it. Got it? Because it is 1/3. When it completes the 0.4 hertz to complete one cycle, it requires 5/2 seconds, while for the 1.2 hertz it requires only 5/6 seconds. So 3 cycles of the second 1.2 hertz will be covered in one cycle of the 0.4 hertz. So the resultant signal will have a frequency of, and we can see that this pattern will repeat itself after 5/2 seconds only, right? So the predominant one here is our 0.4 hertz only. That is why I said that when 1 hertz and 100 hertz are added together, doesn't matter, the resultant frequency will be 1 hertz, and if 2 hertz and 4 hertz are added together, resultant frequency will be 2 hertz itself. So this is a proof for it. So 0.4 hertz and 1.2 hertz are added together, we will get 0.4 hertz as the fundamental frequency. Okay. So please keep that in mind, and now let's take another things into consideration. So this is a square signal. Okay, let this be a square signal. So what did our Fourier claim? Fourier claimed that this square signal is composed of infinite number of sinusoids. Okay. So let us take examples. It contains sinusoids of different frequencies. So let it be 1 hertz, 2 hertz, 3 hertz, 4 hertz, etc., etc., up to infinity. Okay. So 1 hertz and 2 hertz, it will get 1 hertz itself. So the fundamental frequency, even though it has infinite number of frequencies on this signal, the fundamental frequency will be 1 hertz itself, right? We have proved it just before this discussion. So that is why the first we always write sin n omega 0 t. This is our fundamental frequency. All the other frequencies will be the multiple of fundamental frequency. 2 is a multiple of 1, 3 is a multiple of 1, 4 is a multiple of 1. So that is why this n is coming here. So the fundamental frequency is always important while doing Fourier series. Okay, and now let's write it like Fourier said. That is the signal is actually the sum of infinite number of sine waves with the different coefficients. Okay, so that is n is equal to 0 to infinity bn sin n omega 0 t. Okay. So this is what the Fourier claimed. And now we'll just do some postmortem on it. So to find bn, now we'll find bn. So before finding bn, we should talk about the thing called orthogonality of signals. Orthogonality of signals means if two signals of different frequencies are multiplied and integrated, the resultant will be as 0. Please keep this in mind. I think you already know it. If it is of a different frequency, for example 3 pi t and sine 6 pi t are multiplied together, the resultant will be always 0. Okay, that is the principle of orthogonality. And so it will be 0 for everything except sine 2 pi t into sine 2 pi t. If it is of same frequency, we will have a certain value, otherwise it will be 0 itself. So I can conclude like this, that is integral over t sine 2 pi n t into sine 2 pi m t into dt equal to 0 if m not equal to m. Okay. And now what happens if m is equal to n? That is integral over t excuse me, 0 to t, let it be 0 to t sine 2 pi t into sine 2 pi t. What will it be? 0 to t sine square 2 pi t dt, right? So if we integrate, we will just make it into cos 4 pi t divided by 2. From here I will get 1 by 2 minus 0. Please solve it, we will get the answer. That is t by 2, okay. That is 0.5 t. So when n is equal to m, we can generally write it as like this. Sin 2 pi n t into sin 2 pi m t. When m is equal to n, the answer is 0.5 t. Okay. And now we will see what happens here. F of t equal to summation n is equal to minus infinity to infinity bn sin n omega 0 t, right? Take from 0, okay. So it will be b1 sin omega 0 t plus b2 sin 2 omega 0 t plus b3 sin 3 omega 0 t plus etc. up to infinity, right? So now let's find b1. To find b1, if I am going to multiply this f of t by sin omega 0 t, the only one that is going to remain is this component, right? Because all the other component will be equal to 0 because of orthogonality. Because sin omega 0 t into sin 2 omega 0 t, we will get 0 itself. Likewise, sin omega 0 t into sin 3 omega 0 t will give us 0 itself. Okay, we are going to use this principle for finding out b1. Okay, so integral over 0 to t, let it be 0 to t, f of t sin 2 pi t, let it be 1 hertz, okay. 1, let the time period be 1, okay. F of t sin 2 pi t dt. We will see what we will get, okay. So integral 0 to 1, instead of f of t, we are just going to write this sin 2 pi t only, okay. Omega 0, instead of omega 0, it is 2 pi f. It is given that time period is 1, so it will be 2 pi t only, okay. So b1 into sin 2 pi t into sin 2 pi t. So we know that b1 is a constant 0 to t, sin 2 pi t into sin 2 pi t, we will get b1 t divided by 2, okay, right. So for getting b1 t divided by 2, we have to multiply 0 to t f of t sin 2 pi t. So what about b1? b1 is equal to 2 by t, 0 to t f of t sin 2 pi t, right. So that is for b1. So what about the bn? 2 by t, 0 to t f of t sin, there will be only one change, n omega 0 t dt. So this is the formula for bn. We got the formula for bn, right? That is okay. So this is a formula we all study right away. That is bn is equal to 2 by t integral 0 to t f of t sin n omega 0 t. This is how it came into being. So studying the derivation will help us remember the formulas much more better, I think. So also we should know about the concept. So the next thing is okay. Now let's consider a scenario where f of t is an even function. For example, if it is a cos function, we know that cos into sine will yield us 0 only. So bn will not hold into place where f of t is even. So at that time we will come with an. So it will be like 2 by t 0 to t f of t cos n omega 0 t dt. No change other than a cos, because to incorporate even thing. So we don't know, we know that this function will comprise of both even signal and odd signals. So if it is only of odd signals, or sorry, even signals, bn will be equal to 0, and we cannot represent the signal in terms of Fourier series if that's the case. So to eliminate that, we are introducing an. Okay, and now I can write like this. F of t can be written like this: n is equal to 0 to infinity an cos n omega 0 t plus sigma n is equal to 0 to infinity bn sin n omega 0 t. So when n is equal to 0, what happens? This component will be 0 and this will be equal to a0 only, right? So I'll write a0 just outside, and the rest will be n is equal to 1 to infinity an cos n omega 0 t sigma n is equal to 0 to infinity bn sin n omega 0 t. So this is the final formula for a Fourier series expansion. Please keep this in mind. And a0 equal to 1 divided by t0 integral over t0 x of t dt. Okay, a0 is actually the average average value of the function. Okay, so that is it. Okay, now let's have some conclusion over here. Please note this down. If the signal is symmetrical about the time axis, then average value will be equal to 0. Okay, so this is like sharing some important points to be noted while studying, while doing problems on a Fourier series. That is, if x of t is an even signal, then bn equal to 0. Okay, when x of t is an odd signal, an will be equal to 0. If it is having hidden symmetry, that is, if it is a half wave symmetric wave, x of t is equal to minus of x of t plus or minus t by 2. Please have a look at if it is satisfying this property, then it is said that it is having half wave symmetry. If a signal is having half wave symmetry, then harmonics of odd harmonics will only be present in the signals. Okay, odd harmonics, that is 3, 5, 1, like that. That is omega 0, 3 omega 0, 5 omega 0. These kind of frequency signals will only be present in the signal. Okay, odd harmonics will only be present. Okay, and now let's see what is the relation between this trigonometric Fourier series and also the exponential Fourier series. Okay, so f of t, we know that it is equal to a0 plus sigma n is equal to 1 to infinity an cos n omega 0 t plus sigma n is equal to 0 to infinity bn sin n omega 0 t. And what is cos n omega 0 t? I can write it in the exponential form like j n omega 0 t plus e raised to minus j n omega 0 t divided by 2. Likewise, sin n omega 0 t, excuse my handwriting, I hope that you are understanding this, n omega 0 t minus e raised to minus j n omega 0 t divided by 2j. Okay, so I am going to substitute this in our main equation, that will be x of t equal to a0 divided by 2 sigma an into e raised to j n omega 0 t plus e raised to minus j n omega 0 t divided by 2. Similarly, plus sigma bn into e raised to j n omega 0 t minus e raised to minus j n omega 0 t divided by 2j. So we will see what we will get by simplifying. taking the real part only, you will get, that is not the real part, I am sorry, it is a e raised to j n omega 0 t part only. So it will be a n divided by 2 e raised to j n omega 0 t minus j into, I can take it like this, minus into, simplify it, we will get this answer, j n omega 0 t divided by 2, like this. Again, sigma a n divided by 2 e raised to minus j n omega 0 t plus j into b n divided by 2 e raised to minus j n omega 0 t. Okay. So from here, a 0 by 2 sigma a n divided by 2 into, we will take e raised to j n omega 0 t outside, it will be a n minus j b n divided by 2 into e raised to j n omega 0 t plus sigma a n plus j b n divided by 2 into e raised to minus j n omega 0 t. So we know that x of t in terms of exponential Fourier series, it will be c x of t is equal to sigma n is equal to minus infinity to infinity c n e raised to j n omega 0 t. So we will just okay. So we will just compare this over here, we will get Cn equal to, that is positive Cn equal to a n minus j b n divided by 2, because let me write it like this. If it is negative to 0, okay, let it be minus 1, okay, 0 we will write c of minus n e raised to minus j n omega 0 t plus again this will be at n is equal to 0, it will be c0 and e raised to j 0 will be equal to 1, again c0 plus sigma n is equal to 1 to infinity, it will be Cn e raised to jn omega 0 t. So comparing, we will get Cn equal to an minus j bn divided by 2, because e raised to jn omega 0 t is over here, and the other one c0 equal to a0 divided by 2 and c of a minus n equal to an plus j bn divided by 2. What is this actually? C of a minus n. C of a minus n equal to an plus j bn divided by 2, which is actually the conjugate of this, right? Cn star. This is an important conclusion. Cn star equal to C of minus n. Please keep everything is in mind. So we can conclude Cn equal to an minus j bn divided by 2 and C of a minus n equal to Cn star and C0 equal to A0 divided by 2. So this is the conclusion, and then Cn equal to an minus j bn, right? So Cn equal to 1 divided by t integral over t by 2 to t by 2 x of t e raised to minus j n omega 0 t dt. Okay, this is another equation to be noted. being, we can get it by substituting the value of an and bn here and applying e raised to I theta equal to cos theta plus I sin theta. Please do it by yourself. I will get it. Okay, so Cn equal to 1 by t integral minus t by 2 to t by 2 x of t e raised to minus j n omega 0 t. This is another formula to be remembered. So with that being said, I'll end this video. In the next video, we'll be discussing about the properties of a Fourier series, which will be very useful. These formulas all we have studied today are very useful for GATE as well as engineering point of view. So please I wouldn't say by heart, but know the reason behind how these equations came into being and understand the concept, and for doing the problems quickly we should remember these equations. So these are very important equations. Please keep these equations in mind, and I hope all of you have understood what I am teaching. And please have a look at my Instagram account also, which is given in the link to it is given in the description box. If there were some problems and practice questions, problems and short notes like this are shared. So thank you for listening and have a nice day. Thank you.